Hello and welcome to our Introduction to Low Power Wi-Fi webinar. Today's hosts are me, Finn Boetius, Product Marketing Engineer here at Nordic, and Johannes Glaropoulos, the Technical Product Manager for Wi-Fi. First off, some practicalities. If you've seen our webinars before, you're used to this. The duration for this webinar will be about 50 minutes, followed by a 10-minute Q&A. Your questions are highly encouraged. For that, please use the question function, because at the end of the Q&A, we'll have a look through the questions we get there. If you want to talk during the webinar, you are free to use the chat, but for the Q&A in the end, we're going to use the question function. So the chat, I have to mention, is also not anonymous, so everybody will be able to see your initials. And if you still have more questions left after the webinar is done, you can always go to DevZone and post them there. And as usual, a recording of this webinar and the presentation we're showing are going to be available after the webinar. Usually it's about a day afterwards. And we also have 2 sessions of the webinar, so you'll be able to see the Q&A from both sessions. So we'll cut them together and upload it. Yeah, and for that, you can go to webinars.nordicsemi.com/on-demand. The agenda for today is we're going to have a short look into the embedded Wi-Fi market. Then we're going to look into Wi-Fi 6 and how is it enabling low-power Wi-Fi. I'd like to go a bit deeper into target wake time and OFDMA. Then we're going to have a look into Wi-Fi's, into Nordic's Wi-Fi technology. And then I've called this section Synergy between protocols. You can also think of it as between Nordic products. So how to use them in conjunction. And then we're going to close it off with a Q&A. So very brief about Wi-Fi, just to put this into perspective. The global economic value for Wi-Fi in 2022 was $3.5 trillion. There's about 18 billion devices in use, and there's 4.4 billion annual shipments of Wi-Fi devices. A bit more than half of these are Wi-Fi 6. And about half of the global traffic in local access point or in local access technologies is run through Wi-Fi. Wi-Fi is basically everywhere. And that's also what the Wi-Fi Alliance, who are managing the Wi-Fi standard, what their mission basically is, or their explanation of what Wi-Fi is supposed to do. It is supposed to connect everyone and everything everywhere. And I think they're doing a pretty good job because everybody's using Wi-Fi. So, yes, Nordic expands into Wi-Fi. The first question we get a lot of the times is why? Followed by why now and not earlier? So because Wi-Fi has for a long time been the #1 requested capability from our customers. So everybody's been asking us for Wi-Fi for years. And we had the chance to acquire the Imagination Technologies Group's Wi-Fi development team together with the IPs. So we, at a point about 3 years ago, we were able to get a whole bunch of really talented Wi-Fi developers, hardware developers and software developers, and integrate them into Nordic. And that's how we got all of this expertise to make Wi-Fi products. As with everything that Nordic does, our focus is on low power wireless. And now with Wi-Fi 6, it is even an attractive solution to have low power Wi-Fi products. And since we have multiple products that already work together with Wi-Fi a lot, we use the NF Connect SDK also for our new Wi-Fi products. So we're unifying all wireless technologies into one powerful RTOS. The RTOS in this case is Zephyr, which is in our NF Connect SDK. To get product-ready protocols, stacks, and even libraries. Wi-Fi in embedded, enabling the IoT. So what's great about Wi-Fi, basically? And several things. The first thing that comes to mind is native IP connectivity. So a lot of the time, what you want to do is use the internet for the Internet of Things. And it's a lot easier if you can use IP all the way through the process. And Wi-Fi obviously enables you to do that. So there's no bridging needed. You can have a direct connection to the cloud, and you don't require an extra modem, especially in ecosystems that need a modem, like, for example, Meta. You have higher throughput compared to other protocols like Bluetooth Low Energy or Thread. And you can even get even higher throughput with the 5 gigahertz band. And that's another great point, that you actually have more than just one band to use. So this enables new kinds of applications. Then we also have longer range compared to other 2.4 gigahertz protocols again. And so it's also well suited for ranges that are slightly outside of what you could use otherwise, or what you would need to use a mesh network for otherwise. And a really big one is ease of deployment, because as I mentioned before, Wi-Fi is basically everywhere. So a lot of the cases you have an existing Wi-Fi infrastructure ready to go that you can just add your devices into. So, and you also obviously eliminate the need for gateways, because you will have Wi-Fi in most cases where you want to deploy a new device. And Wi-Fi is also addressing the centric IoT requirements. One of the ones that is now addressed, but wasn't really before, is the power efficiency. So you have really efficient power saving schemes, one of which is the most impactful in my opinion, I will go into later in this presentation. So you actually can get moderate current consumption. You have robust performance. I think that's an obvious one for Wi-Fi. And you have really high security now with WPA3, private and enterprise even. Okay, now let's have a look at what in Wi-Fi 6 actually enables it to work so well for low power. Okay, so let's have a look into Wi-Fi 6 enhancements. There's several. These are the ones we think are most important, but these aren't all necessarily interesting if your target are low power applications. So we have downlink MoMIMO. We have OFDMA that allows basically sharing of bandwidth. We have beamforming, allowing you to directly target a device with a message, basically like spatially. We have more or bigger channels up to 160 megahertz. There's longer symbol duration. There's target wake time, which is, in my opinion, the most important feature when it comes to low power. There's BSS coloring. There's up to 8 spatial streams, which is why you get some of these fancy-looking routers with 8 antennas attached to them. And there's higher modulation. So what are we gonna look at for our Nordic devices? Since we're focusing on low power, this is what the new Wi-Fi device that we brought to market earlier this month, the NF 7002, will support. We'll support OFDMA, we'll support beamforming, longer symbol duration, target wake time, and BSS coloring. That is beamforming on the receiver side, obviously not on the router side. What I want to talk a bit more about in today's presentation or in today's webinar are these two, OFDMA and target wake time. When it comes to power saving schemes, there's a relatively big difference between target wake time and what we had beforehand. What you can see here is this is called legacy PSM, so the legacy power saving mode. That's using DTIM and will not allow an end device to have much of an impact on its own power consumption, because you have to be awake at the beacon periods anyways. The target wake time power saving mode is a lot more flexible in this way, because what you can do is you can negotiate a wake up schedule. So the device can negotiate with the access point how often it wants to talk to it. What that means is you can decide on your latency, for example, and also your sleep time. So you have very good and granular control about your power consumption. So you will basically just do the data exchange at the point where you want to. And obviously, more than one device can be included in this. Another big point that this helps you with that you don't immediately see is it mitigates contention in the channel. So it's easier to make sure that the channel is free at a given time. How does it look like? What we did here is we took our power profiler, attached it to one of our NF 7002 DKs, and ran through different power saving modes. The red rectangle you can see here, that's no power saving mode. So that's basically constantly on. Then when we take a look at the legacy power saving mode, we'll try to sleep a lot of the time, but this sleep time is mostly mandated by the access point. So you can't really change what you want to, or how long you want to sleep. And oh, by the way, these peaks here, that comes from measuring those, so that's not part of the application. And then if you can have a look at target wake time, in this case, we chose the time of 10 seconds, and you get a lot more sleep time. You have control over your sleep time. So this is really interesting for this. Yeah, it's a really good overview of how the power consumption is compared to other power saving modes, I think. If we take a bit more, or if we take a better look at this, I zoom in. Here, this is the target wake time with a 10 seconds interval. What we're gonna see is the sleep current here, and this is over the host SoC and also the companion IC. So in this case, we have 5340 and the NF 7002. We'll have an average of 15.3 microamps in sleep. And then over the whole communication, we'll go to about 5 milliamps, 500 microamps with the on and off times. So pretty good power saving scheme. And obviously you can choose these intervals freely. We also have different intervals in the product spec that we tested and wrote the power consumption in there. We also have a really good section in our documentation for an overview of power saving schemes. So if you want to have a look in the NF 70 series documentation, there's a really good overview of different power saving schemes that'll also tell you which power saving scheme is the best, because you might actually have a situation where it's more beneficial to use DTIM instead of target wake time. And it shows you how to do the proper setup if you want to do a measurement or for traffic and current consumption, for example. And it shows the APIs. So this is a really good spot if you want to learn a bit more about power saving schemes. I also put the link in here. So when you get the presentation, you can click on it, but you can also just find it now and read up on it. Obviously, pay attention to the webinar first and then read it. Okay, that was target wake time and a quick overview. Now I want to go into OFDMA. It's orthogonal frequency division multiple access. So the short answer of what it is you take basically one channel. So these are 20 megahertz. This is one Wi-Fi channel, and you divide it up into multiple subcarriers. In this case, 117 on both sides. So you have a really high number of subcarriers, and you also have the longer symbol duration. So what you can do is, let's say you want to use the same channel with 3 different end devices, so client 1, client 2, client 3. You can divide these subcarriers so that device 1 talks on these subcarriers, device 2 talks on these, and device 3 uses these subcarriers. So you have a very you have opportunities to subdivide the frequency. This sounds a bit complicated, and it also can be. But the good thing for us is that it is complicated only on the access point side. And we are in low power usually working on the station side. So from a station's point of view, this basically just means you have a smaller frequency band to operate on, and don't really have to take into account the complexity of mixing this frequency and getting the signals apart. So you basically just get a different frequency that you have to talk to and use that, and other devices can talk on the same channel at the same time. This is really useful for, let's say, you have a big sensor network where you have lots of devices that don't need to send too much data. Without using OFDMA, you might run into contention. So there might be too many devices trying to talk, and even though they don't have a lot of data to send, they might block the channel for a relatively long time. And this is a really good way to avoid that. A very simple way to think about this is coming back to our big picture where we had the explanation of OFDMA. So you want to send one package of data, and you put data for different devices into that. A good way to symbolize it, what we did here, is we just have the frame be a truck. So this is a truck, this is what the truck is loading, and we put the data for 3 different devices in here. This data goes to device 1, this goes to device 2, and this goes to device 3. So instead of having 3 trucks on your very small road, or slightly bigger road, you will just have 1, which obviously leads to a less busy road. To conclude, the reason we started our Wi-Fi journey with Wi-Fi 6 is because we think it's really attractive for IoT application. And that was one of the main reasons why we wanted to start our Wi-Fi journey with Wi-Fi 6. Okay, and with that, we had a very good overview of our power saving schemes. And now I want to give the mic over to Johannes to talk a bit more about our NRF70 series.
All right, so let me also welcome you to this webinar, the Introduction to Low Power Wi-Fi. The following few slides will walk you through Nordic's NRF70 series of Wi-Fi 6 companion ICs, and the NRF7002 in particular, which is the first variant of this series. So, this is an executive summary of the NRF70. First, let us stress again that the NRF70 is a series of Wi-Fi companion IC devices which can add Wi-Fi capabilities to other system-on-chip or microcontroller hosts. Besides being Wi-Fi 6 capable, NRF70 series devices are dual-band capable. They feature a Wi-Fi radio with low power capabilities. They support advanced Wi-Fi security features, and they have support for ideal coexistence with Bluetooth Low Energy and 802.15.4 radios while operating the 2.4 GHz band. In addition to that, NRF70 series devices are supported in Nordic's NRF Connect SDK, the software development kit for all modern generations of Nordic ICs. And finally, NRF70 devices will come with a Wi-Fi 6 certifiable stack, allowing our customers to make end products that can be Wi-Fi 6 certified. This slide presents the highlights of the NRF70 series. NRF70 ICs support Wi-Fi operation in both the 2.4 GHz and 5 GHz bands. They are Wi-Fi 6 compliant when operating in station or client mode, making use of newly introduced winning features of Wi-Fi 6, such as OFDMA, TWT, and BSS coloring, as Finn discussed earlier. NRF70 is of course compatible with earlier 802.11 standards. Now, NRF70 devices feature Wi-Fi radios with one spatial stream, supporting 20 MHz wide channels and 64 QAM, and this results in up to 86 MHz nominal physical layer throughput. The devices will support all main operating modes for Wi-Fi: station, software-enabled access point, and Wi-Fi Direct, as well as dual mode, for example, station mode concurrently with either SoftAP or Wi-Fi Direct. NRF70 series devices are companion ICs and support both regular and quad SPI interfaces for communicating with the host processor, and they are currently available with standard QFN packages. This slide presents an overview of the planned IC variants of the NRF70 series. NRF7002 is the full-featured variant, supporting all Wi-Fi modes and dual-band operation. As you may know or may have heard, NRF7002 was launched recently, but Nordic is planning to launch two additional variants. The NRF7001 device, which enables all Wi-Fi operating modes, however, is a device that will support Wi-Fi operation in 2.4 GHz band only. And then also the NRF7000 device, which will be a dual-band capable device, however it will only support passive and active scanning of Wi-Fi access points. It will be a cost-optimized variant, and its aim is to be used in Wi-Fi based locationing applications that are supported with SSID based scanning. NRF7000 IC will be an ideal companion to 9160, Nordic's narrowband IoT solution, or any host device that wants to add location services via Wi-Fi SSID scanning. Now let's look at the block diagram. So as shown here, the NRF70 series devices include the analog and the digital parts of the Wi-Fi radio transmitting and receiving functionality, and implement the physical and the medium access control layers of the 802.11 protocol stack. The IC includes an integrated power amplifier for the transmitter, a power management unit to implement low power modes, and one-time programmable or OTP region for storing device information, and a control block to manage communication with the host processor. As mentioned, the NRF70 devices may send or receive data to and from a host processor over SPI or QSPI. The device features an additional 3 or 4 wire interface, which may be used to manage coexistence with host platforms that include the Bluetooth Low Energy or an 802.15.4 radio. Okay, so let us look briefly on the radio operating parameters of the NRF70 devices. Transmitting at maximum power and with the highest modulation rate consumes around 190 and 260 milliamps in the 2.4 and 5 GHz bands respectively. And these numbers are at typical voltage input levels. Receiving Wi-Fi packets consumes around 60 milliamps. In sleep mode, when the radio is not active, current consumption is down to less than 15 microamps, and that is required to run an RTC and retain state information in the internal memory. When the device operates in the various Wi-Fi power-saving modes, it spends most of its time in the sleep state. Now, in the absence of data transfer requirements, devices in power-saving mode wake up only to maintain the connection to the access point. TWT allows the NRF70 series devices to run with extremely low average current consumption. The device will consume less than 30 microamps on average when operating in TWT with 1 minute wake-up period. And then for more aggressive duty cycle operation, the average current consumption will go down even more, and eventually it will be dominated by the sleep current. In the NRF7002 product specification, which was published last week, we present current consumption performance figures for both TWT and legacy DTIM-based power-saving modes. Now, as mentioned, NRF70 series devices will be Wi-Fi 6 certified. In addition to that, as part of the core specification, The certification program for the NRF70 ICs will include Agile Multiband, Enhanced Open, and wireless multimedia extensions for power saving. The certification program will also include Wi-Fi Direct as one of the supported Wi-Fi operating modes. We discussed earlier about that. And also Easy Connect, which defines a standard for securely commissioning devices into Wi-Fi networks, reducing complexity and enhancing the user experience. And since we're discussing Wi-Fi Alliance certification, let me tell you that as part of the NRF 7002 product launch we did last week, we published a white paper in our info center to provide important guidelines to our customers for achieving Wi-Fi certification status for their end products that are based on Nordic's Wi-Fi solution. The paper is published in the info center, but we give a direct link to it also here. This white paper lists the certification programs for which the NRF 70 series devices will be certified, and gives a nice overview of the certification process defined by the Wi-Fi Alliance. The document describes Nordic's chosen programs and paths to streamline the process of delivering Wi-Fi certified solutions. So, in this white paper, we address the most important questions by our customer, which is, what is the appropriate and most cost-effective path for customers to achieve the Wi-Fi 6 certified status for their end products based on NRF 7002? Finally, let's talk a little bit about security. The NRF 70 series will support WPA3, looking at providing higher grade security protocols and more robust authentication solutions. Obviously, legacy WPA and WPA2 security protocols will also be supported. It's important to mention that WPA3 implementation is split between the host driver and the NRF 70 firmware. So our added value here is that NRF 70 series implements part of the WPA3 support, so it removes the need to implement that in the host driver. So effectively, we remove complexity and overhead at the host side. What is implemented in the companion IC firmware is the actual data pipe encryption algorithms, as well as the key exchange for the simultaneous authentication of equals. WPA3 support is extended to both personal as well as enterprise, when Wi-Fi devices are authenticated based on user account certificates. As mentioned, Enhanced Open is part of the certification program, and it is mostly implemented in the host side, assuming the underlying Mac stack supports WPA2 and or WPA3. And with that, I conclude this section, and I hand it back to Finn to talk about synergies between wireless protocols.
Thank you, Johannes. So, as mentioned before, I want to go a bit into the synergy between protocols, or you could also say between the NR70 series and Nordic's portfolio. So, Wi-Fi and the NR52 or 53 series SoCs. We have some applications that are enabled by Wi-Fi that aren't otherwise possible. Mostly this is due to bandwidth requirements. So let's say you want some video cameras. It's a lot easier to stream video using Wi-Fi than it is to stream it via Bluetooth Low Energy, for example. So in this case, we get up to 68 megabits, which is a lot. And we also have the QSBI connection to the host interface. We get the slightly higher range in a normal use case. So that's also a plus. And then we have the extra security with WPA3, personal and even enterprise support. And you also have the option to encrypt the SPI communication between the host and the NRF70 series. So you don't have to be afraid of somebody opening up the device and trying to sniff out the communication that way. So the target applications we have here, good ideas, for example, audio or video streaming. You can, in this case, battery-powered devices that usually don't work well with Wi-Fi, but they now do. So, for example, for some door locks that might have a battery life of about 2 years, you can still run them using Wi-Fi, and then they just have about 1 year. But that's a lot better than what was possible before. And usually a door lock is one of those devices that aren't really in reach of your smart hub in the house. So but your door lock usually is within Wi-Fi range. Always connected devices like home appliances and sensors work really well. And this is mostly due to you have a pre-existing network everywhere where you want to use them. So you have Wi-Fi and you don't need to set up an extra gateway. And you have a bit longer range, so everything that's outside of your door is really good to use Wi-Fi for. We do have a really nice dev zone block that I want to mention at this point. We set up a block about implementing NQTT over Wi-Fi on the NRF 7002 development kit. It sets up a bidirectional MQTT connection, and you can build it yourself. Usually, I'd expect most of you to be able to do this in about 15 minutes. And it's really cool because you can just set up an MQTT app on your phone and flash the hex file and control some LEDs on your development kit via your phone, and also send information from the development kit back to your phone, which is also a really nice use case. We're also working on including this in the next release of NRF Connect SDK as an official sample. This one's still based on an MQTT example from our cellular SIP. But yeah, really interesting read, and really nice to set up an easy and fast MQTT sample. Okay. Now let's have a quick look at how this looks like. Okay, and then I want to go into Wi-Fi and the NRF 52 and 53 series again, but this time applications enhanced by Wi-Fi, not enabled. So one of those really nice use cases is Wi-Fi offloading. So let's say you have an application that's usually using Bluetooth Low Energy, for example, but you have certain use cases where you want to transfer a lot of data at once. So let's say you have some devices distributed about a large area. A good example could, for example, be some of those smart scooters that are in most of the city at this, at least here in Norway, they're in most of the cities. It's really good to just have a Bluetooth connection to talk to the phone that's close by. But at some point, let's say you want to do a device firmware update, or you want to get a lot of data of where the scooter has been off of it. So there's one guy driving through the city on his truck that needs to do a device firmware update. You really don't want to use Bluetooth for that one. And in this case, you can just switch from Bluetooth to Wi-Fi and use the faster protocol for the firmware update, and then switch back to the more energy-saving one. You can also use it in applications where you need to use higher security for some reason, or anything that is battery powered but also needs to transfer a lot of data. One example that I myself have discovered a lot of the time is if you have a smartwatch that doesn't support Wi-Fi and you go for a long trip, for example, it collects a lot of data. Like if you have a smartwatch, it collects a lot of data on where you've walked and your heart rate and whatsoever. And when you want to get that onto your phone, it sometimes struggles and takes 10 to 20 minutes to just transfer that data, which can be very annoying. And a really nice use case when you have a smartwatch that supports Wi-Fi is you can just get the data over to your phone really, really quickly. So those are really nice use cases for enhancing other applications with integrating Wi-Fi. Another really interesting use case is Meta. It's Meta, for those who don't know, it's the new smart home standard that is supported by basically all major smart home ecosystems. So Apple, Google, Amazon, Samsung SmartThings, all of them are supporting this. And it's a really yeah, it's a really good smart home standard, and it's very likely going to be unavoidable to support this in at least some way with the smart home devices going forward. And with this matter, usually the communication, if it's wireless, happens via thread, which is 802.15.4 based. So it's using the same radio as Zigbee. It's a really nice low power mesh, works for most applications. But if you have higher bandwidth requirements, you will want to use Wi-Fi. And now you have the option to add the NF7002 next to your existing chip to also support Wi-Fi. This is also useful, for example, if you build devices and you want them to be able to be the first smart home devices in somebody's house. Because at that point, they don't necessarily have a thread-capable router. And then your device needs to be able to support Wi-Fi to connect to the local network. So it gives you a lot more flexibility. And yeah, so you can use thread for low power, or you can use Wi-Fi for easy integration. Yeah, basically, yeah, you can use Wi-Fi for easy integration. This leads me straight to the next use case, which is gateway solutions. Let's use Meta as an example again, because there are some device manufacturers that went very heavily into Zigbee, for example. And most of them are now working on gateway solutions. So what that would mean is you want to be able to still use all of your old devices, but have them integrated into Meta. And this is where Nordic devices fit very well together, because if you look at a 52 or 53 series device, you have Bluetooth Low Energy, you have Thread, you have Zigbee all in one device. And then you can add the NF7002 next to it and build a very easy gateway application from any low power protocol, low power mesh protocol, for example, to Wi-Fi and build a gateway solution. It's a really good communication of short range mesh protocols and Wi-Fi. And obviously, we've worked very hard on making the coexistence of the different protocols work very well in our devices. Cloud, and you get a very accurate or relatively accurate location data back. So in a lot of use cases where we have asset tracking, the NF9160 cellular SIP is a really good device to use, because you have the cell connection and you have GNSS. So let's say you want to have GPS for a really accurate, location. And if you want a more rough location, accurate to 100 or 200 meters, you can also use multi-cell based locationing. So you look which cell phone towers are close by. But if you want to have something that's in between, so you want to be more accurate than the multi-cell, but less power hungry than GPS, this is where SSID-based Wi-Fi locationing fits very well in. Another really good point to why to add Wi-Fi to any asset tracking application is Wi-Fi tends to excel where GPS struggles. What do I mean when I say that? So in the cases where GPS doesn't really give a really good result is, for example, if you're in the middle of the city with high buildings close by, or if you're indoors, you don't really get a good GPS signal. But what you do get exactly in those situations is you have a lot of Wi-Fi networks close by that you can use for SSID-based Wi-Fi locationing. And also the other way around. Everywhere where you don't have Wi-Fi networks close by, so where SSID-based locationing doesn't really work. Let's say you're out in an open field, no Wi-Fi nearby, so you can't use it. But those are the use cases where GPS works really well. So they're really complementing one another very well. So how does that look? Oops. How you would do it is you take a 91 series device, you add the NF70 series device to it, and you request Wi-Fi information from nearby networks. So what you will get is you get the MAC address, you get an SSID, get the signal strength and the frequency. And this information you can take and send it via the 9160 to the cloud via cellular connection. And in the NF cloud, we have several Wi-Fi databases. So we can input these information into a database and send you back your location with the longitude, latitude, and also an uncertainty. So we can tell you, okay, you are here with an accuracy of about 30 meters, for example. So this is a really nice solution, and it's already integrated into our NF cloud. And we have several of Wi-Fi map makers, so of these location datas, and we'll compare the data always to multiple of them and send you the best result back. So you don't even need to do with that. You can just use the NF cloud for that. We also did a test drive to see how good the results are. This is our first test drive where we had GPS running and we had GNSS running and had the cell-based locationing next to it. So you can see the green line, that's basically the accurate line that we drove. That's the GPS location. And then you get several points where we're not as accurate with the cell-based locationing, but you can still get a rough location. So if you don't need to know on 10 meters exactly where you are, cell-based is still a very good way to use. But then we checked the same thing out with SSID-based Wi-Fi locationing, and we get this. So as you can see, we get a lot closer to the actual route that we drove with the car. Here we are a bit off. I'm assuming it's because there's not as much Wi-Fi networks. But yes, so very good and accurate location data we can check. This test drive was in Tampere because we have an office there and we had somebody who could do the test drive for us. Okay, and with that, we went into all the synergies that I wanted to express and can go back into technical details. And for that, I'll give the mic back to Johannes.
Okay, so let me take over the last section of this webinar to cover some technical aspects of the NRF70 series a little bit more deeply. Let us look again into connections and interfaces of the NRF70 series devices. As mentioned earlier, NRF70 series supports SPI and QSPI for data and control interface to a host processor. For QSPI, there is the additional option of having the whole data transfer between the host and the NRF70 device encrypted. Host microcontrollers may also use the backend signal to enable the NRF70 device. And then there is also a host IRQ signal to asynchronously interrupt the host processor. To realize Wi-Fi coexistence with Bluetooth Low Energy or 15.4 2.4 GHz radios, there is a GPIO-based 3 or 4-wire coexistence control interface. And I will give more details about this in the following slide. Now let's just focus on something very, very important, the software stack. The NRF70 series is a companion IC and includes firmware which implements the medium access control layer of the Wi-Fi stack. The networking applications, as well as the higher levels of the TCP/IP networking stack and the Wi-Fi driver, they all execute on the host MCU, for example, on Nordic's NRF5340 SoC. The software stack on the host side communicates with the MAC layer on the NRF7002 through SPI or QSPI. The Wi-Fi driver presents control and data interfaces to the TCP/IP networking stack, and it also includes the WPA supplicant, which takes care of managing the Wi-Fi connections. The Wi-Fi driver software, including the supplicant, is provided as open source, and it's delivered as part of the Nordic's NRF Connect SDK. The driver implementation is based on and tailored to Zephyr RTOS, which is the core of the NRF Connect SDK. But since it's fully open source, it can be easily ported into other RTOS solutions, as we can discuss later. Now, let us go back to the coexistence solution. At first, let me remind that the coexistence solution aims to mitigate the interference between the Wi-Fi radio and a Bluetooth Low Energy or a 15.4 multi-protocol radio, which may be present on the host processor or any other co-located IC. Why a coexistence solution is so important? For example, when the Bluetooth Low Energy radio receives a packet, it's important that the Wi-Fi radio does not transmit on the 2.4 GHz band. So there has to be some sort of coordination between the two radios. The NRF70 series devices feature a wireless coexistence control logic based on a generic packet traffic arbiter or PTA with request, status, priority and grant signals. The PTA receives requests from the multi-protocol radio for transmit or receive transaction, and it may grant these requests based on the priority or the status properties which are signaled through the corresponding lines. The coexistence hardware enables flexible output signals that support interface configurations like 3-wire or 4-wire. And in addition to that, the coexistence algorithm allows the Wi-Fi and the multi-protocol radio to share the same antenna for 2.4 GHz radio operations. With a shared antenna between Wi-Fi and Bluetooth Low Energy or 802.15.4, both the size and the cost of a final product may be reduced. Now let's get back to the OTP memory discussion. NRF70 series devices include an OTP that is partitioned into factory OTP and user OTP. Factory OTP holds information related to production as well as stream values. Now, user OTP may be programmed by the customers in production. It contains regions for customers to program the device MAC addresses, the QSPI interface encryption key, as well as device calibration coefficients that may be programmed in order to enhance some performance characteristics of the device. To protect accidental programming of the OTP, we have added a logical protection scheme and an additional voltage level based protection. And in the Wi-Fi radio test sample inside the NRF Connect SDK, we document the available APIs to program the OTP memory. As we have mentioned a couple of times already, the NRF70 series devices will be fully supported in the NRF Connect SDK, Nordic's unified SDK for all modern and next generation ICs. Already in the last NRF Connect SDK major release in December, we have included development support for the Wi-Fi stack, as well as several examples. In the second quarter of 2023, we aim at providing production support for the Wi-Fi stack in the Connect SDK. Now, the software support includes the open source host Wi-Fi driver, as well as potential firmware patches for the NRF70 device. Software support is complemented with several applications and examples that showcase our Wi-Fi APIs and major Wi-Fi functionality. We have samples that enable developers to get started with Wi-Fi on NRF70 series and the Connect SDK, but also more complex examples showing how to use Bluetooth Low Energy to securely provision NRF70 devices into Wi-Fi networks, or how to add SSID-based scanning in location services, and how to enable the Matter stack and Matter applications over Wi-Fi. We also showcase how to enable coexistence in the Wi-Fi stack, and also how to configure devices to run in low power mode. So please visit our SDK main page because we continuously add new examples and applications for Wi-Fi. So we want you and our customers to use the NRF Connect SDK to develop Wi-Fi applications with the NRF70 series devices. However, we do not restrict you to do so. NRF70 is a companion IC, and therefore it can be used with third-party hosts and other OS or RTOS solutions or ecosystems than the NRF Connect SDK. There are some obvious requirements for that. So first, the selected host devices need to have SPI or QSPI peripheral support in order to interface with NRF70 devices. And second, The selected RTOS environment needs to have an implementation of the networking stack, so at minimum a TCP IP stack, but preferably upper layer networking protocols commonly used in networking and IoT applications. And then, if these requirements can be met, all you need to start using the NRF70 series devices is to port the Wi-Fi supplicant and driver onto the RTOS of your choice. We have enabled you to do so by providing the Wi-Fi driver in the Connect SDK as open source and with an architecture that is mostly RTOS agnostic, so the software porting effort is moderate. And let me close this section with presenting our first development kit for Wi-Fi, the NRF7002 development kit. So this TK features the NRF7002 IC and the NRF5340, Nordic's latest generation multi-protocol SoC as the host processor. The development kit is supported in our SDK and is available already at several distributors. And as I mentioned earlier, the TK comes already with a rich set of Wi-Fi examples, but the list of examples and applications is continuously enhanced. NRF7002 is an ideal companion, but not only to NRF5340. We also want to see designs with NRF52840 or NRF9160 as host processors, in different application use cases, of course. In the upcoming months, we will launch more development kits for the NRF70 series that will allow customers to easily evaluate applications with Wi-Fi on NRF52840 and NRF9160 SoCs. And now back to Finn for the concluding remarks.
Thank you, Johannes. So if there's anything you take from this presentation, this is a really good point. What does the NRF7002 device do? First off, it is dual band capable, so you can run it in 2.4 and in 5 GHz. It is very low power and secure, and it has built-in coexistence, optimal coexistence with Bluetooth Low Energy and our other protocols, like, let's say, Thread. It is supported in NRF Connect SDK, also implemented to work with our NRF Cloud examples, and it will very soon be Wi-Fi 6 certified. And with that, I think we can go into the Q&A. Can you comment on Wi-Fi 7 as the existing Nordic Wi-Fi module is only Wi-Fi 6? So Wi-Fi 7 is still a work in progress and it's not released yet. And the improvements in Wi-Fi 7 are very significant, but they're not really targeted at IoT or at the low end that we're targeting at low power. So not at the moment, but obviously in the future, that is something we'll look into. Then let me click the next one. As the NRF7002 only supports 20 megahertz channels and most Wi-Fi infrastructure is set up for 80 or even 160 nowadays, does this mean that only 20 megahertz around the center will be used, or worse? Okay, the NRF70 series supports 20 megahertz wide channels in the current list of product variants. This does not mean that all devices in the access point will be forced to use 20 megahertz. So the other devices with higher capabilities are still able to use that. And as with all the Wi-Fi channels, right, you can have, or most of the channels are overlapping and can still be used at the same time. So this shouldn't constrain you. Okay, this question. This question is one we get a lot. We get this for every product. We even get this for power management ICs. So it's as always, it's an entirely different device. So an ESP32, it's not really comparable since it's like a complete SoC, so everything in one. And we have a Wi-Fi companion IC that you can add to something. I've had a really nice comment on, I think it was on a blog post that I made, where that question also came up. And since I don't want to go too much into this, I'll just tell you the comment because I really liked it. And it was, there's always a cheaper option, but what you win in cost, you will probably lose in developer frustration levels while developing your product. So yes, if you keep digging, you might find something else that does the job. In this case, though, they are really not comparable since they have a completely different use case. Then let me check. What's the next? Target wake time. Oh, I need to put this in. So how flexible are you when it comes to target wake time? So in this presentation, I might have run over it a bit quickly, but we do have, if you look at the product spec, we have several target wake times that we tested and the average current consumption. I also showed a screenshot of me using the Power Profiler kit to test different target wake times. You are very flexible. So this can be from like way less than a second to more than 1 day. So you are very flexible, like very, very flexible in how you want to use this. This one's basically the same question again. Can it be like 5 minutes? Yes, it can. Then next question. While I understand that I should ask my regional sales manager for this, so there is one for your region. I've looked it up, but there is the rough statement on the timeline and drivers. So station support is coming very soon. Soft AP and WFD are coming later this year. We cannot comment on the exact timelines for Linux support, but we're definitely looking at it. Then this question, I'm not sure exactly at what point it came, but yes, obviously if you have higher modulation, you might run into range problems, but also this kind of modulation like the 1024 QAM, that's not what we are supporting with the 7002. Because it is just not needed for the low power applications. So, and long range, in this case, what I think what you're referring to is longer range as compared to a standard Bluetooth connection. So when everybody has in their mind like 10 meters for Bluetooth, and Wi-Fi has a bit more of a range, so double or a bit more. But obviously, depending on your design, this can change, and also depending on your area. Right? If you go to the US where you can use 20 dBm, you can get kilometers of range out of a Bluetooth signal. Okay, I think Johannes is unmuted. I'll just mute you again unless you want to answer a question.
I can take the next one if you want, Finn. Hi, so you can relax, take a minute, take a breath. So is the next one about the OFDM cell carriers? This is the question.
Yes.
Want to answer? Okay. So why are there OFDM subcarriers not overlapping? Isn't that better use of bandwidth? They actually are designed so they do overlap in a way that they preserve orthogonality. So the adjacent subcarriers, they have the end of the one subcarrier falls at the peak at the center of the next one. So this is why orthogonality is made. So we preserve, like minimizing the interference between them.
Okay, let me check now.
I can take the next one as well. Are there any recommended network configuration when there are many station sensors? Well, that's also, it really depends on actually the traffic pattern. So usually sensors typically don't transmit or receive that much. So networks with dense number of sensors can scale nicely. What I could also comment is that there are many ways for access points to enhance the overall network throughput in these kind of networks. They can use MIMO, they can use multi-user uplink or downlink, beamforming, and also things like come also in Wi-Fi 6, like PSS coloring. So yeah, probably APs can be configured to use all those features to increase the overall network throughput in dense deployments. So next question is Are there any plans for upstreaming the support for the NRF70 series to mainline Zephyr? Yeah, okay, there have been discussions about that. NRF70 support is anyway on the Connect SDK, which is based on Zephyr RTOS. So if you would like to follow those discussions, I invite everybody to join the Zephyr's networking forum meetings where such matters are discussed. Next question, I can take that one. Could the NRF 7002 support something like packet injection and monitor mode, transmissions mode for building or Wi-Fi mesh, maybe the test mode? Yeah, so currently transmissions mode is not supported, and the same thing is for Wi-Fi mesh. So this mode is not currently supported in 7002, but this is entirely firmware, so it may be supported in the future firmware update on the device. I can maybe take the next one, Finn, and then you continue. So will the Wi-Fi stack and the open source counterpart in Zephyr, as with the open source variant of the BLE controller to the soft device controller, or will this remain closed source? So if I understand the question well, we are talking about the medium access control firmware, the 8211, which runs on the 7000 device. That runs from ROM. It's ROM-based firmware. So we see right now not real any benefits of giving that as open source. But yeah, any feedback here is welcome.
Okay. Then I'll get back at the questions. So let me start with this one. What's the range of the NRF 7002 compared to the 5340? So this is a bit hard to say, as this is not an apple-to-apple comparison, since one of them is using Bluetooth, the other one's using Wi-Fi. In general, roughly you could always say like 1 to 3. But then it highly depends on your antenna design. So for Wi-Fi, you have to be really careful with your antenna design. And if you make a really good one, you have really good range. If you don't, you don't. And then again, you could use a front-end module for Bluetooth and get up to kilometers of range. So it's, yeah, it depends is the answer. Then this one, I'm not sure if I understand the question correctly. How big is the DFU package and how often are CVE vulnerabilities addressed? So a DFU package is the size depends on the application, so I can't really like give a direct answer to that one. And if vulnerabilities in general, like that's true for all of our devices, are discovered, and we also have a program where you can submit those and get rewards. So they will be addressed usually in the next release, but if they're very critical, obviously we'll work on them faster.
So maybe I can add a quick comment about the DFU package thing here, if I have understood this correctly. So the firmware that runs on the 7002 can be updated. It needs to come through DFU update on the host side, so on the host processor, like the NRF 5340. Right now, this kind of patches for this firmware are at the size of few kilobytes. So overall, they don't pose a lot of overhead on the DFU of the host processor. It's like a few kilobytes.
Okay, thank you. Yeah, obviously you can also update that device. I was thinking about the host. Yeah, no, that's correct. Then what's the size of the typical antennae? So usually it's, I think it's 3 by 5 millimeters or something on the DK, but obviously you need some additional components. So if you have a look at the NRF 7002 DK, there's 2 antennas on there, and they're both roughly the same size. One is the one we're using for Bluetooth and Thread and Zigbee and so on, and the other one is the one we're using for Wi-Fi. And then you might also need to include a duplexer and stuff if you want to use it on different frequencies. Then, so what's the power consumption on MQTT demo application? So for that, my first comment is that this one is definitely wasn't optimized for power consumption, so I can't really. It can probably be very much improved. We also haven't measured it. This was just proof of concept, so to say. But it's obviously easy for me to measure. You can just get a power profiler kit, get the decay, and start measuring. So, yeah. We also, I'm not sure if I mentioned this in the webinar, so the blog post that we had, the MQT sample that we used there was a sample that we're using for the 9160, so for the cellular SIP. And we just ported it over, or the Ali Al-Jani, the one who wrote the blog article, he just made it work for the NF 7002, which wasn't too much effort. But we are now like officially porting that over, so it works on the NF 7002 and will be integrated in the. It is integrated in the current, in the master branch, but you will also get it in the next NCS release, NF Connect SDK release. And okay. I think this question we've answered a couple of times. Maybe we should have mentioned this in the webinar since it comes up so often. What is the max sleep period in target wake mode? So you can go up to days if you want to. And then maybe we can switch back over to Johannes.
Okay, the first one I see here is, can we use only one antenna on the PCB for BLE and Wi-Fi? Have you tested that? Do you supply drivers on some kind of protocol? Yes. So this is all, probably I discussed that in the webinar before. This is all addressed with a coexistence solution between BLE and Wi-Fi. The algorithm that is supported on NRF 7002 supports both configuration, like one antenna shared between BLE and 2.4 gigahertz Wi-Fi, or separate antennas. So this is all supported, and you can actually test this today with NRF 7002 DK. So the next question is, NRF 52 BLE devices are prone to RF shadowing, where human body attenuates signals significantly. Is NRF 70 Wi-Fi a better option for simple body sensors? Well, again, that's not easy to answer, right? These are two different protocols. Each one has some good features. Bluetooth Low Energy has channel hopping, so probably you address RF shadowing in that way. Wi-Fi uses MIMO, and that helps a lot. For a single input, single output, the usage of guard intervals in OFDM probably helps, but there is not really a one-to-one quantitative evaluation on this. Are there any plans, for an example, to use the NRF 7002 DK as a matter border router, or does this always require Linux? So I assume that you are referring to a thread border router here. So border router is the terminology used by the thread networking project. Yeah, so far we have reference designs that are Linux based in Nordic, but this is like really a very interesting use case. So we would like to see the NRF 7002 combined with a host processor and implement a thread border router in a cost-efficient way. So that's actually an interesting use case. Okay, next one. Maybe I'm actually be skipping a few. This one is actually, I will answer this one because this is related. Would it theoretically be possible to create a thread border router based on NRF 53 and NRF 70? Yes, this is theoretically possible. This is absolutely possible to do. I think there is a question of what kind of resources in terms of memory you have available on the NRF 53. Regarding flash, this can always be solved easily with external flash. With RAM, you can probably also do the same. But it's a more complicated. But other than the memory requirements of such a border router solution based on 53 and NRF 70, I see no other problems of realizing this. What is the advantage on the NRF 70 series compared to the NRF 52 regarding the SSID-based location, so Wi-Fi scanning? I think I'm a little bit confused here. NRF52 is a Bluetooth or 15.4 radio capable device. It does not do SSID based scanning. This is only done through NRF70, which is a Wi-Fi IC. Between NRF91 and NRF70, what is the interface? SPI, QSPI. If I remember correctly, and maybe Finn can also double check that, on the NRF9160, there is only SPI support. So the SPI is the only interface you can use to interface these two ICs. There is QSPI support on 52840 or 5340 that also can be used as an alternative. And it also gives a higher interface speed.
Yeah. So
okay, yeah, go ahead.
Yeah. So we have one demo for this on trade show. So if you want to come to Nordic at a trade show, I think Mobile World is very soon, and then Embedded World in Germany. We do have a demo that shows exactly this. And in that demo, we are definitely using SPI for this connection. And then I think I can just take the next couple of questions. Let's see. Can the NRF7002 support 802.11MC FTM, fine-grained localization, or just use SSID-based localization? So to give this a bit of context, so that's a different kind of Wi-Fi localization that is not SSID-based. It is considered for a future product, but right now we are only supporting SSID-based Wi-Fi locationing. And then, how much resources does the stack consume on the host? What is left for my applications? So in general, you will have, I think, around 200K of flash in station mode, but yeah, it depends on the application. So if you use the 5340, you'll have 800 meg left.
Let me add to this, Finn, that in the NRF Connect SDK documentation, in the same section where we would discuss also low power mode operation, there is a section discussing what you can do with resource constrained host platforms like the NRF 52840, for example. So you can see what kind of compile time configurations you can do to reduce the footprint of the driver and the supplicant.
Okay.
So I invite the people to take a look into our documentation about that.
Yeah. Then one of my favorite questions: where to get the NRF7002 development kit? The very easiest way is to just Google it. They're available at several distributors. You can also go to nordicsemi.com/NRF7002 DK. Or just go to the page and navigate to the development kit. There's a buy now option. So if you click that button, we have we have something integrated on our webpage that shows the stock of several distries. So you can see who has it on stock and to which price, and then order where you want to order or where it's cheapest. So just go to our homepage, NRF7002, or nordicsemi.com/NRF7002 DK, and you'll see who has it on stock if you click the buy now button. Okay. Next question. I think I can take this one too. What is it? Could you also combine the powers of Wi-Fi and cell-based locationing when requesting the position from NRF Cloud? Yes, and this is something that is done by default. So when you use the NRF Cloud or when you use Wi-Fi based locationing, the way you get the information to the cloud is by using a cellular connection. So you always have the cell information basically baked into it because you are communicating with that cell tower. So that is automatically happening when you use NRF Cloud. Okay, we are a lot over the time, but maybe we can take one or two more questions. Is there something you want to answer, Johannes?
Okay, I can take the next one. Is the power consumption of Wi-Fi 6 low power modes comparable to that of previous specialized solutions such as the Renesas or the Silicon Labs? Well, yeah, I don't want to comment that much on competitive solutions. I will only say that, yeah, of course, these are old chips, data sheets are available, so you can do a one-to-one comparison if you want. I just want to mention that if I remember correctly, both of those solutions are Wi-Fi 4, so 802.11n compatible, so legacy Wi-Fi. And also, if I remember correctly, they're both single band 2.4 gigahertz solutions, so they're essentially not comparable with Nordic's Wi-Fi 6 device.
Yeah, so you wouldn't be able to use any of the Wi-Fi 6 low power features. And you would also force the network those devices go into to work on the old Wi-Fi band then. So if you integrate the Wi-Fi 4 solution into a Wi-Fi 6 network, you can't use the proper Wi-Fi 6 low power features anymore, even for the other devices. Okay,
I can take the next one, but I think these are all very interesting questions. Like they are very nice. I think I can also answer the one about the antenna system. Yes, there is, of course, the diplexer is a passive device, so there will be some kind of signal loss there. I think the same may apply for the antenna switch, but I think the effect is minimal there. I mean, you can have diplexers with minimal with loss. Should the soft AP example be operational already? No, that's not correct. Soft AP mode is still planned until it will come in one of the next releases of the Connect SDK. So you cannot run soft AP today. What is available today with the Wi-Fi shell is station mode, so client mode on the Wi-Fi. And what would be the expected average current with the TWT of 1 second? We don't have all those numbers in our datasheets yet, but this we're actually looking to providing a nice overview of simulated and measured results of TWT performance on different wake-up cycles and durations. So please wait for updated documentation here. Just a last comment, I would say that TWT of 1 second might in many cases be not practical. So for such small periods, TWT would still work, but you can also consider legacy power saving mode like DT-based as an alternative. Finn, to you.
Yeah, since we're now 17 minutes over, I think we'll stop for now. We still have lots of questions left. So what I'm trying to do is we have a second session of this webinar that is for us this evening. So it's in 8 hours. We'll try to get some of these questions also in that Q&A. And if you can't join, you can still watch the on-demand upload that I'm doing of this webinar later. And we'll combine the Q&A of both of these sessions in there. We got some question that was multiple questions that were related to what happens if I want to use this with a Wi-Fi 5 system. So the short answer is it works, but obviously you can't use the low power features like target wake time, for example, that are in Wi-Fi 6. And also the other way around, if you want to use if you want to use, for example, target wake time, yes, your router will need to support Wi-Fi 6. Then questions towards the average expected current consumption. We had that in the presentation. You can also download the presentation, then you will have it in there. But we also have sample values in the product specifications for different target wake time values. It is not going to be an automotive part. And then what else do we have? Is it the better choice to use it with the NF52840 or with the NF5340 SoC? And this mostly relates to what you want to do with your application. So obviously, if you can make it run on the 52840, which has a bit less processing power and less storage, then that is a good option. You have more processing power on the 5340, and you also have a bit more, it is more efficient. So if power consumption is a very big point for you, the 5340 is there also the better option. And now let me take a look into today's questions. Okay, we start with the first one. It should be on screen now. Yeah. What are the advantages that brings Wi-Fi 6 over Z-Wave for home automation? And this is a very, very broad question, since it's not entirely comparable. So there's several advantages that Wi-Fi has in general over Z-Wave when it comes to this. So the sub-gigahertz spectrum, especially when it comes to the manufacturer side, you have several different frequencies you need to operate on depending on which country you are and which region you are. So sub-gigahertz can be a nightmare when it comes to antenna design and getting certifications for it. And you can expect the infrastructure to be existing if you use Wi-Fi. So if you build a device that's the first device that comes into a new home, you can use a Wi-Fi device because every home will have Wi-Fi, well, basically every home. And that's definitely not the case for Z-Wave. So there you always have a higher barrier of entry for the end customer. And then again, I'm not an expert on Z-Wave. Yeah, and if you really want to use a low power mesh, it's most of the time a better way to use Thread. Or you also want to probably, if it comes to home automation, go into Meta, because that's supported by all the big ecosystems. And then you're going to run on Wi-Fi or Thread anyways. So I think it's basically unavoidable to use one of those two. Okay, that was a very long answer. Another very broad question. What's the major advantage of the NF7002 over existing Wi-Fi controllers available in the market? And I think in most cases it's a case-by-case comparison, so it depends on what you want. The very easy answer is if you're using a Nordic device next to it, like any Bluetooth sock for provisioning, for example, then this is always going to be the better option, just because we basically built the whole application already for you. So we have really good coexistence with Bluetooth Low Energy, for example, and it works amazing with other Nordic devices. We also very low power. Not all of those devices support Wi-Fi 6, so that's a really big point towards this. And we have taken very good care to have it work very well in coexistence with other protocols. Then a bit of a longer question that I'm not gonna put on screen because the screen is then probably not visible anymore. It's basically a dev zone question that needs a bit of tech support. There's also a dev zone ticket attached. So it's somebody trying to run a UDP sample, and I've checked on the dev zone post. It had new activity this morning, so I'm expecting there will be a better answer for you. But we're also looking at a dedicated sample when it comes to UDP for the for the NF7002 DK. Okay, let's check. Unfortunately, I missed the start of the webinar. Will this be reviewable later? Yes. You can go to nordicsemi.com/webinars and look at the on-demand webinars. We will also upload this to YouTube in a day. Then, how close in terms of power usage can Wi-Fi 6 with target wake time function come to LoRaWAN? This is, again, not an easy comparison. And it's also worth mentioning that target wake time is a power-saving mode, and it sits on top of the Mac and Fire layers. So it's really hard to answer this question. So you need to look at at what you're trying to do with your application, basically. Okay. Next question. Okay. Do you have any solution or application nodes, for example, which might act as a bridge to Wi-Fi, to a Wi-Fi network, like Bluetooth LE bridge to Wi-Fi. That is definitely a use case we are looking at. Oh, Johannes?
Yeah, please go ahead answering this.
Okay. So it is an interesting use case. There's basically nothing stopping us from just making a gateway, and the fact that they're like, yeah, we are considering a reference design that basically solves this problem. So it's like how to add IP connectivity to Bluetooth LE. That's basically what you want to solve with this. And yeah, it is definitely a use case. Then, I didn't have this question earlier. Can range be extended with Wi-Fi 6 somehow?
Yeah, I can maybe take this one,
Yeah.
Finn. So yes, so Wi-Fi 6 comes, actually Wi-Fi 6 release 2 comes with some features that can help extend the uplink range from stations to the access point, and we take advantage of those things. Then there is a question. I can take some questions, so you can take a quick break before handing over to you back. So how about bit rates? I'm not sure I understand well this question. I think I mentioned in the presentation that we are doing 20 megahertz wide channels and MCS7, up to MCS7, so that gives you up to 86 megabits per second nominal rates. Obviously, payload bit rates is lower because of the nature of the medium access control. Maybe you want to take the next one? Okay, next question is, does access point need to be Wi-Fi 6 to support client wake-up time functionality? Yes, these are all introduced in Wi-Fi 6. So if you want to use TWT with the Nordic IC, you need an access point that supports it. Next question is, can access points have configuration to allow longer sleep times with legacy Wi-Fi? Yeah, define longer here, so it's not also easy to answer this question. So of course there is legacy power saving mode, what we usually refer to as DTIM base. So DTIM can go up to a number that it can give you some good duty cycling. Also, there is a feature that allows stations to maximize their idle time so they can sleep more. But in that case, also they can miss packets from the access point. So this doesn't come without any cost. Next question is, what would be the expected bandwidth in the 10 seconds TWT example? Yeah, so all of this could, I mean, they have a lot of variables they depend on, so it's also hard to answer. But if I can make up an example on top of my head, you can transmit and receive a lot of packets in a TWT session. So when you wake up to send and receive traffic from the access point, I think we have in our APIs, we have a default duration of 8 milliseconds, but this can also go up more. So in that period, you can receive, and if you can receive at maximum rate, and if no other station is trying to access the medium, then you can get all the channel for yourself. So that probably is the cap. You can it's the maximum rate you can get. Okay, Finn, want to continue?
Yeah. One question was regarding to availability. That's pretty easy. So you can get the IC now. The best way to do it is get in contact with your local sales. Obviously, the development kit you can buy via distribution, but the IC should also be available. So you can go to your Nordic distributor or your Nordic salesperson, and you will be able to get your hands on the IC itself. Let me check. I lost track where we are in the questions. Okay, my questions seem to have disappeared. I will have to go through this way.
So maybe I can continue. Sorry to interrupt, Finn. So I look at the questions on the questions chat on my window. So there is a question: how long the initial connect to access point can take, like seconds or milliseconds, or this depends from the access point firmware. This is really deterministic, or actually it does not have that much variation. So a device that is on and is not associated to the access point, it usually takes a few milliseconds to connect. We have seen that, we have measured that, we have tried that and tested that with many access points. So I would say safely that this is in the order of milliseconds. What takes a little bit longer is that if you have the device in shutdown mode, and then you want to measure the time until that it can be associated to the access point, then you need to include the boot up time of the device that potentially also downloads the firmware patch to the device. So we have some numbers around that in our product specification. You can take a look, you can download the document. I think we specify something around 400 milliseconds for a device that is basically shut down until it can reach active mode and then connect to the access point. But for devices that are already up, this is like a few milliseconds. Next question was, can Wi-Fi 6 enabled edge device work correctly with Wi-Fi 5 or Wi-Fi 4 access point? Yes, that's Wi-Fi 6 is backwards compatible with previous versions. So it's no problem having an older version of your Wi-Fi access point at home. NRF 7002 will connect well, but it won't use Wi-Fi 6 features, obviously. Does Nordic have plans to leverage Wi-Fi 6 new capabilities to offer enhanced indoor location capabilities to cloud services? Yeah, that's a question also a little bit also touching roadmap. So for now, I think the focus is on providing location assisting through SSID-based scanning, which is something that is also can be done with legacy Wi-Fi versions, because this is where most of the interest is found. Next question is, what use cases will most benefit from OFDMA? So that's also hard to say, but one thing that it comes up to my mind, and actually it's pretty important to say, is that when you have dense network deployment, so a lot of stations with heterogeneous traffic requirements, then OFDMA gives a more flexible allocation of bandwidth and resources to the stations, so makes a better usage of those. So I would say that in dense network of devices that are of different kinds, OFDMA and Wi-Fi 6 is going to help. Yeah, can you continue, Finn, from here?
Yeah. Is there an extension to the 6 gigahertz band, so Wi-Fi 6E in this case, planned for your products? So this one doesn't support it. So we have 2.4 and we have 5 gigahertz. But yes, that is something we obviously are looking into. It's a band that has been used, but we don't have anything planned at the moment. But obviously, it's a band that that is interesting. Then is the Linux driver available for the NRF 70? So at the moment, not, but we are definitely working on this. So this is something that is interesting for us. So we are looking into it. Okay, how is the companion IC managed? What is the strategy for OTA? So if you have a NRF 52840 host and the NRF 70 companion IC. So OTA is basically the same thing as a device firmware update, just we're referring to OTA over the air in when it comes to cellular most of the time, and DFU when it comes to Bluetooth. So yes, you can do that separately for the NRF 7002. And for the 52840, it would work the same way it does now. But you can do a device firmware update for both of them.
Yeah, so let me add to this one that the firmware for the NRF 7002 or the NRF 70 series devices is running from ROM on the device. The functionality we have there in place to be able to update the firmware is to have a firmware patch that is loaded onto the device at boot. So a firmware upgrade to the NRF 70 series basically means that you need to upgrade this patch. And this patch is delivered as binary as part of the host driver. That said, whenever you need to do a firmware upgrade for the NRF 70, basically you need a new driver version for the NRF 52840 host or whatever other host you're using to interface the NRF 70. And let me comment about also the footprint. There was an interesting question on the earlier webinar about that. So this patch currently is in the order of a few kilobytes. So it doesn't really bring a significant overhead on the OTA for the host device.
Okay. Do you want to keep going?
Yeah, I can take the one that you have here on the screen. So how can the NRF 70 be used in wearable devices without access to access point? So I think I mentioned that in the presentation, we're going to support software-enabled access point. So basically the device itself can act as a software access point. And we're also going to support Wi-Fi Direct in one of the upcoming firmware releases. So these are two modes where you can actually use the device in a more ad hoc mode, so without a physical access point. So the next question is, can I use the NRF 7000 for DFS radars detection? I think this feature is not available on the NRF 7000.
I think this question has been answered before, in which use case OFDMA is the best one. Then we have more about Wi-Fi 6 or about 6 gigahertz. That has also already been answered. Okay, maybe I missed the information. Is the chipset able to connect to a non-Wi-Fi 6 access point? If yes, what about target wake time? I think we also had this one. So yes, it is backwards compatible. You can connect it to all the access points, but then you won't be able to use the Wi-Fi 6 power saving modes. But obviously, if you can't use target wake time, you can use the legacy power saving mode, for example. So you are constrained by the access point in that case. And then why does the NRF 70 achieve higher range, for example, compared to Bluetooth devices? And this is obviously a statement that is not true in all conditions. So generally, you can say an average Wi-Fi connection has a longer range than an average Bluetooth connection, but this also depends on how you implement it, right? You can do a lot more on Bluetooth than you can do on Wi-Fi when it comes to extreme ranges. So let's say you are in the US where you can use 20 dBm and you want to use a front-end module, then you can get kilometers of range on a Bluetooth connection. But this is a statement that is true for like the average Bluetooth low energy connection and the average Wi-Fi connection. Just have a bit more output power, so you have a bit more range. And in general, you can think of Wi-Fi to be about 30 meters and Bluetooth to be about 10 meters. Obviously, as an engineer, you know this is very dependent on the use case and what surrounds you and how the antenna design is. But yeah, that's why we made that statement. It's not true in every sense. But in general, you can achieve a slightly higher range. Please show a chart that shows current consumption. So this is actually interesting because we are considering making an app where you can put in different target wake time schedules, for example, and get the estimated power consumption out of it. But as I mentioned before, you will be able to get some of these informations out of the product spec. But you will also, you can just test it. You can just get an NRF 7002 DK, change the target wake times, and set it up to a power profiler. And depending on what you want to use it for, it's always better to test yourself than to see what's in any data sheet. Can you send the recording of the session? Yes and no. So it will be uploaded here, where you will get a notification if you signed up via email. It's also going to be available on the on-demand webinars and on YouTube later. Does the kit have a jumper to measure the current usage? Yes. So we have 2 extra connectors for current measurement. I think one is directly for the NF 7002, and the other one is for the NF 7002 and the 5340 that is on the kit. So the answer to your question is yes, we have 2. Then a question about the MQTT demo. Does it use target wake time? No. The easy answer for this is no, because this demo was written on a software that's actually made for the NF9160, our cellular SIP. So we just quickly ported it over to the NF 7002 to make it work there. That is more of a proof of concept, and that's what my colleague did. I think Ali Aljani wrote that blog article. He just wanted to show that it's possible, and so we just changed the demo. We are also working on an official sample that does the same thing. MQTT phone example. Does the user need to disconnect from the primary Wi-Fi network and connect to the NF 7002 Wi-Fi, or is it possible to be connected to both at the same time? Oh, not at all. So what we're actually doing is you are using the Bluetooth on the development kit, and then you're using your phone to provision the kit to the Wi-Fi network. So the only connection after that, so you will use your phone for the commissioning of the DK in the Wi-Fi network, but after that they're only communicating over the server. They don't even have to be in the same Wi-Fi. So the development kit is connected to your Wi-Fi, talks to an MQTT server somewhere, and your phone can be wherever it wants to be. It just has to have connection to the cloud. So they are not connecting, like they're not directly talking over Wi-Fi to one another. That's the beauty of this demo, kind of. Yeah. So no, they don't have to be connected. Is there an upper bound for the target wake time interval, considering clock drift?
Yeah, so I can maybe answer this one, Finn, if I can interrupt. So regarding the upper bounds, I think there is obviously a software API limit to how much we can support on the TWT interval. That's quite high, though. I think it can go up to days or even more. I don't remember the actual number. But the clock drifts will be there for sure. That's it's a good question. It's a good comment. So what I saw is that the device itself, so the internal firmware, will compensate in advance for long TWT intervals, and then this means that it will take into account possible clock drift, and it will wake up earlier than the negotiated time to account for impairments in the clock drift. So this also means that if you use very, very long TWT intervals, then obviously you need to account for some slack when you wake up because clocks are not perfect.
Okay.
But this is something that the device does internally. So this is nothing that the user needs to worry about.
Yeah, I think we can maybe, Johannes, if you want to pick and choose one more question, we still have way too many, and we're already 20 minutes over the time. I can answer one in the meantime. So this is has been asked before. Can you use it in automotive products? And here the answer is very obviously no, you can't. So our devices are not meant for automotive use. I think we have one device in the 51 series that is for automotive, and all the other devices are not. And maybe,
yeah, and so they were all very nice questions. My apologies that we did not manage to answer all of those on time, but they are really many and really interesting. Some of them highly technical. So I maybe if I can pick one easy and quick question to answer more of this remaining ones is about the FreeRTOS support. So this is something that we don't provide in our SDK. We have in our NRF Connect SDK based on Zephyr RTOS, but like as I said in the presentation, our driver is fully open source. And it's mostly RTOS agnostic, so you can take this and port it to FreeRTOS.
Okay. Then as the very last question to answer about modules. So there are already some module makers that I think the only one who is in production that I know of is Funstel at the moment. But there will come a lot more modules. So we know of several module makers that are working on this. And you will very likely have your favorite module maker make a module based on this. And there are ones that are just using the NF 7002, but also in combination with, for example, the 5340. You can go to third-party modules. The easiest way is to just Google Nordic third-party. And on our website, we have an extra page that also lists the currently available Wi-Fi modules that will expand if more come. Okay, and with that, thanks a lot. And also for staying this long extra in the Q&A. We appreciate this a lot. And we'll also try to get one or two more questions answered and maybe include them in the Q&A so you can have them on the on-demand video. So it's a bit after the webinar, and we still wanted to go through some of the questions that we weren't able to answer in the webinar. So let's start. You mentioned the NRF 52840 as a host MCU. Does the SDK also support the NRF 52832? Sorry, no. The main reason is it doesn't have enough RAM. Then we have a question about someone who is teaching a STEM education class and if it is possible to get in contact with Nordic. I think the best way for that would be to get in contact with the Nordic Developer Academy. Maximum transit power and range. All of the specs are in the spec sheet. For transit power and range, I think we even have it in the handout for this presentation. So you'll be able to find it in there. How does the supplicant decide to stay in Wi-Fi 6? What parameters dictate the supplicant going back into legacy mode? So the supplicant does not decide this. If the access point supports Wi-Fi 6, then the NRF 7002 will operate in Wi-Fi 6. Legacy power saving, and this is the question, is selected by the user via the user API. So the user can switch to legacy or to target wake time. The supplicant won't make this decision. Well, this question is missing a bit of a part, but it's asking if you can run the MQTT example while target wake time is active. And the answer is probably yes, but we haven't tested it yet. So this would be an interesting showcase. Has the NRF 70 been calibrated in end of production? So obviously the kits have been calibrated if you're talking about the kits. But then again, yes, if you are producing a product, you will have to do some tuning at end of production. And then we have another question about modules. And I think I have mentioned this before. So there are modules available and you can find them if you, like the easiest way to find is Google Nordic and third-party modules, and then you'll and you'll definitely find what you need. We have another question about the size of the battery you choose, and in this case it was specific to thin film LiPo batteries or ultra thin LiPo batteries. So it's very hard to answer a question like this. So what you would need to do is figure out your use case. What do you want to do? How much data do you want to send? And you can reference our product spec to see the power consumption that use case would show. And based on your battery, you will figure out either how long you last on a charge, or you need to figure out the size of your battery depending on how long you want it to charge. And then again, you will get estimates if you take those numbers. So what I recommend you to do is build the application and do the measurements yourself. That's the only way where you will have accurate, where you will get an accurate answer to this question. So it's very hard to give you a general rule of thumb, especially if we don't know which kind of battery you're using and how much data you're sending and so on. And if you need help with that, I always recommend posting a question in DevZone, and you will get a response. Okay, and with that, we are done with our additional questions, and thanks again for listening in.